So welcome. This video is for 5 Further Mathematics FP1 for day 3. In day 1 we have covered question number 1 to 10. Now from question number 11 to 15. The quadratic equation x square plus kx plus 2k. So sum of the roots is going to be nothing but what? Minus b upon a, which is going to be negative k. Product of the roots is going to be c upon a, which is 2k. Find an equation whose roots are alpha upon beta and beta upon alpha. So first I'll find sum of the roots, which is alpha square plus beta square upon alpha beta, which is alpha plus beta whole square minus 2 alpha beta divided by alpha beta. So which is minus k whole square minus 2 times 2k divided by 2k, which is going to be k square minus 4k divided by 2k. Then k cancels, it becomes k minus 4 upon 2. Then I am going to find it out, the product of the roots. Product of the roots is alpha upon beta times beta upon alpha, which is going to be 1. Once I know the sum of the roots and the product of the roots, formula is x square minus x times sum of the roots plus product of the roots is going to be equals to 0. So it becomes x square minus x times 1 upon 2 times k minus 4 plus 1 equals to 0. Question number 12. Show that alpha minus beta whole square equals to so on. So I take alpha plus beta whole square minus 4 alpha beta, which is alpha square plus 2 alpha beta plus beta square minus 4 alpha beta, which is alpha square minus 2 alpha beta plus beta square, which is alpha minus beta whole square. Now the new equation, this has the roots alpha and beta. Show that. So sum of the roots is going to be nothing but what? Minus b upon a, which is going to be 6k. Product of the roots is going to be c upon a, which is k square upon 1 k square. He is asking alpha minus beta whole square. So which is alpha plus beta whole square minus 4 alpha beta, which is 6k whole square minus 4k square, which becomes 32k square. So what is alpha minus beta? Square root of 32k square, which is 4 square root 2k. Find a quadratic equation whose roots are alpha plus 1 and beta minus 1. So first I am going to find it out, the sum of the roots, which is alpha plus 1 plus beta minus 1, which is alpha plus beta, which is 6k. Then I am going to find it out, the product of the roots, which is alpha plus 1 times beta minus 1. Expand it out, you get alpha beta minus alpha plus beta minus 1. So which is alpha beta minus 1 minus common alpha minus beta, which is k square minus 1 minus 4 square root 2k. So once I know the equation, sum of the roots and the product of the roots, so x square minus x times sum of the roots plus product of the roots is going to be 0. So x square minus x times 6k plus k square minus 4 square root 2k minus 1 equals to 0. Coming to question number 13. The roots of the quadratic equation are given as p and q. So what's going to be the sum of the roots? Minus b upon a, which is nothing but what? Minus 1 upon 1, negative 1. Product of the roots is c upon a, which is going to be negative 8 upon 1, which is negative 8. Now what is being asked? P plus q plus 1 upon p plus 1 upon q, which is going to be p plus q plus p plus q upon pq. So which is negative 1 plus negative 1 upon negative 8, which is negative 1 plus 1 upon 8, which is going to be 7 upon 8, negative 7 upon 8. Question number 14. The cubic equation has the roots alpha, beta, gamma. Use substitution x equals to square root of u. So it becomes square root of u cube plus 5 square root of u whole square plus 7 equals to 0. So u root u plus 5u plus 7 equals to 0. So u root u equals to minus of 5u plus 7. Then again squaring on both sides. So it becomes u square times u equals to 25u square plus 70u plus 49. Then it becomes u cube minus 25u square minus 70u minus 49 equals to 0. Now we know that x equals to root u. So u equals to x square. So what will be the roots of this equation? The roots of this equation will be u equals to alpha square, beta square and gamma square. Now alpha square beta square plus beta square gamma square alpha square will be equals to c upon a. What was c? Negative 70 upon 1, negative 70. Lastly, question number 15. The cubic equation has the roots alpha, beta, gamma, x equals to u minus 1. So plug in that one. So it becomes 2 times u minus 1 whole cube plus 3 times u minus 1 minus 3 equals to 0. So it becomes 2 times u cube minus 3u square plus 3u minus 1 plus 3u minus 3 minus 3 equals to 0. So 2u cube minus 6u square plus 6u minus 2 plus 3u minus 6 equals to 0. So 2u cube minus 6u square plus 6u plus 3u is nothing but what? 9u minus 8 equals to 0. So we know that x equals to u minus 1. So u equals to x plus 1. So what will be the roots for this one? Alpha plus 1, beta plus 1 and gamma plus 1. I want alpha plus 1 times plus beta plus 1 times gamma plus 1, which is nothing but what? Product of the roots. Product of the roots is going to be nothing but how much? Minus d upon a. So negative d is nothing but what? Negative d upon 2, which is going to be 4. That completes this video. See you in the next video for this day 3, where we have 11 to 15 questions. Now in the day 4 we will be doing it out from 16 to 20. So every day try to do only 5 questions for this further math. That will be helpful for you getting it at a good score in further pure mathematics for this chapter. See you in the next video. Bye.